Today, we are group 2. We are going to present our final project for sorting line, and now we are going to present the HMI. So that was the first screen. Now moving on to the main screen. So at the HMI, we have the inputs, which is the 4 buttons. We have also the conveyor and also the pistons. We also then have the counter for each objects, the big, tall, and the small objects. Then we also have the indicator, which are the system on lamp and the emergency lamp. So to start our cycle, the conveyor will turn on and the system lamp will turn on also. And then we also have the stop button. So what the stop button does is that it will stop the sequence, but it will not reset the sequence, but it will continue the sequence that is left over. Okay, now it's stopping and the system on is blinking. Then when it starts, it will pursue its leftover sequence. Now we also have the emergency button. So when we press the emergency button, the emergency lamp will turn on and the system lamp will blink. Now if we press the emergency button, if it's still toggled, then we cannot start the process. See? And no lamp is on. So in order to continue the sequence, we need a reset button and a cleanup procedure. So what reset does is it executes the cleanup procedure, that it cleans the queue count, it clears the object in the conveyor belts to the reject. So it passes all the sensor S5, S7, and S9, and it goes all the way to S11 and then to the reject chamber. So you see the queue count is decreasing. It is cleaning up the items. Alright.
Now we are going to talk about the logic. So I'm going to start the system now. And I'm going to put, for example, 8 items here. First, I'm going to walk through all of the requirement. For example, the first item that I'm going to talk about is the big item, which needs to be detected by S2, S3, and S4. As you can see, the sensor detects it, and it will give the output after the item leaves the sensor, which means that after all of the sensor turn off, it will give the input that it is a big item. And then when it passes through S5, it's going to be S5, it's going to be pushed. At S5, it's going to be pushed, then meaning the item won't be detected by S5 anymore, it turned off. Then the item is pushed to the conveyor, meaning S6 will be turned on. When S6 is turned on, the piston retract, and after the item leave S6, it will put the queue count, and the conveyor M2 will turn off after 2 seconds, just like the requirement. And the M2 is turned off, as you can see, when the S5 is detect the item. Then moving on, I'm gonna test now the tall item, which the requirement is S2 and S2 or S3 or S4. The sensor detect S1 and S2, and the item is leaving. That's why of the and when the item is leaving, it will give the input that it is a tall item. It will move to S5. The sensor will detect it S5. It's not gonna push it, and when it reaches S7, it's gonna push it, and the conveyor M3 will turn on. It being pushed, the item is no more at S7 and is now detected by S8. S8 will make the piston retract, and after the item leave S8, it will put a queue count on the tall object, and it will turn off the conveyor M3 after 2 seconds. Then moving on to the small item, which can be it's either S2 only that turns on or S4 only that turns on. S2 is turned on, and then the item leave the sensor, the force sensor part, meaning the sensor turns off, then giving the output that it is a small item. It will move at S5. It passed through S5, as you can see. Then it moved to S7, and it passed through S7, and then it passed through S9. In S9, it will detect it. It will turn on conveyor M4, and it will being pushed. S9 no longer detected, and it's being pushed to S10. And at S10, it detect the item. The piston P3 retracted, and once it's leave the item, leave the sensor as 10, the small object count will be increment to 1, and the M4 will turn off after 2 seconds. So as you can see, that the logic works when the object big is detected. It will move it to big object. If it's tall object, and so on. And for safety, to make sure that the sensor always stay correct, if you saw before, that the input will only be detected if the item big, tall object, or small will be detected after it leaves all of the sensor, to make sure that it is actually a big object, a tall object, a small object. By doing so, we can make sure that it is, so we can make sure that the tall object is actually a tall object. A tall object moving from S1, S2 to S3, S4 won't be considered as a big object. So it's kind of a safety measure. Then another logic that we put down is is by using the shift register and also delay. Why do we use this? Well, this is because, for example, at the requirement, it say that the item is not always side by side. It can be gap, it can be side by side. I just show you when the item has a gap, it works perfectly. But what happens if the item is close to each other? To take example, I'm going to show first. There's going to be a small item, for example. A small item. It detects a small item. And then right before it can go to S5, it then also detects a tall item, as can be seen. It detects a tall item. First, the tall item will pass through S5, and it shouldn't be pushed. As you can see, it's not going to be pushed. And when the small item is moving to S5, it's moving to S7. It's not going to be pushed also, as can be seen. Right when the item is at S7, S5, the item, that tall item before, is pushing through S5, and the system is still working, as you can be seen. When the item moved from now the small item moved from the S7 to the S9, it can be seen that it being pushed. And when the small item is going to S9, the tall item previously at S5 moved to S7, which is now being pushed to the tall object count. Then the system go on like usual. The S9 item is being pushed by the piston. It's going to S10. The piston retracted, and after it leaves the sensor, it will give the small object count. And then after it leave being pushed by the piston F2, the tall item before is no longer at S7 and is being pushed to S10. Is being pushed to S8. Where is S8? There we go. S8, where it will receive the item. It will retract the piston, and it will make and once the item leaves the tall object count, it will receive, as you can and it will turn off. As you can see, even if the item is compact together, the system will work. This is one of and another scenario where the system is close to close. For example, we use shift register as a logic. Shift register might have problem with if there's a big object moving first, and then before it can reach S5, there's also another object, for example, a tall object that is blocking the S5 sensor. That might be a problem with shift register. That's why we put a delay logic in it, so we can complement it. So already put there's a big item right before the big item can go to S5. There is a tall item moving in. A tall item moving in. There we go. So the big item is going to pass through S5, where it's going to be pushed. There we go. It's pushed. It went being pushed to S6, and then it detected and it went back, as can be seen. And then right after the big item, the previous tall item is being pushed to S5. It passed through S5, and it can be seen it's not being pushed, and that it will go to S7, where it's going to be stored. There we go. It pushed to S4. It's received at S8, where it will be it will retract the P2, and by doing so, there we go. We have the item, and it turns off. Oh, and for the rejected area, we haven't tested. Rejected area is basically the item is not big, tall, or small. For example, if only S1 that is on, it will be considered as a rejected item. As you can be seen, it's going to be considered as a rejected item. It will go to pass through S5, where it's not going to be pushed, for example. Then it will go to S7, past S7, where it's going to be open. And then it's gonna, I forgot to turn off S9. It's going to be pushed through S9, where it's not going to be pushed. Then it's going to end up going to S11. So as can be seen, this S11 sensor detected, and with the item leave the sensor, it will give the Q count that the item is rejected. And that is all. This is the logic. The logic is this is the delay part. The delay part, which used a delay like a second to give output. to make sure that the system, even if the item is side by side, we can still get an accurate reading of whether it is tall, it is small, correct blocking. And this is the shift register that I use for each P1, P2, P3 to block the piston from pushing the wrong items. There we go. That is the logic in the system, and it can be seen that it works well. So then I can, if I want to start the system again, maybe I can start it. I can put like a different item, maybe two item. Once again, I can put it into big item first. Let the text a big item, and then it's going to push it to S5. It push it, turns on M2. It moved to S6 and retract, and there. The S12, S13, S14 right now is not being on. This is because this should be part of the sensor that is connected to the piston. The piston, since we don't have like the actual piston, meaning that we, for this simulation, for the sake of being fast, the S12, S13, and S14 will be simulated later on at the logic part by Pharaoh. And
error logics. The first error we got is when the product is detected and is moving, and then S5 is on, but the S12 is still off, making the piston doesn't push. That is the first, and that code, and we got error code of 10. The next one is that,
and the system also stopped.
and all the system is stopped. And then the next one we got is the error code of 20, which is both S5 and S12 are on, meaning that the piston is push the block in, but S6 doesn't detect at all. And then the next one is the error code 25, which the piston already pushed the block, S6 already turned on, but the product still doesn't move at all. Making the other, meaning that the S12 and the S12 doesn't work. And then the next one we got is an error code that happened at S7, which also has the same thing as the S5 problem, but instead it has the code of 30. The next one is also like, the next one is the error code 40, which is similar to the error code of 20, except is in the second row, which is for the tall object. And then the next one is also similar to the problem in problem code of 25, which is the problem code 45, which the S8 doesn't detect the product at all, but it still turned on, meaning that product is stuck. The next one is the error code of that happened in S9, which mean that it's also the same as S5 and S7, which the product is detected and is being pushed, but it doesn't push, the piston doesn't move. And then the S14 also similar to S12 and S13, which it is moving, but it's stuck in there. And then the next error is the error that happened in S10, which similar to S6 and S8, But for the small object, it seems that it's still stuck on a conveyor. And there's the error code of 65.
There we go. After 10 seconds the error.
After 10 seconds.
That is all for the error logic. According to the requirement, error logic, logic, and the HMI. That is all for our project. We already put the counter sequence. We already put make the HMI. We already put the error logic, as it can be seen. And that is and our project can sort it. That is all from our presentation and our project. Thank you.